Hello, good morning. Welcome to day 9 of Advent of Code. Glad to have you here. We are well on our way to the tropical island, day 9 out of day 25, out of 25 challenges in total. And let's get to it already. Yep, encoding error. So I'm gonna read out the puzzle, the challenge, and I'm gonna think out loud as I go through solving it. And if you have any question about my approach or whatever I'm writing down, let me know. I'll be happy to explain. Or if you just want to chat about the puzzle and how funny it is that we are the backstory, feel free to just say hi in the chat. I'm keeping an eye on it. All right, so day 9, encoding error. With your neighbor happily enjoying their video game, you turn your attention to an open data port on the little screen in the seat in front of you. So we're in the airplane right now, and we fixed our neighbor's game console in the previous day's challenge. You turn your attention to an open data port on the little screen in the seat in front of you. Though the port is not standard, you manage to connect it to your computer through the clever use of several paper clips. Interesting. Upon connection, the port outputs a series of numbers, the puzzle input. So that's going to be our puzzle input for today. The data appears to be encrypted with the exchange masking addition system, Xmas. Christmas, that's funny. Which, conveniently for you, is an old cipher with an important weakness. Xmas Christmas starts by transmitting a preamble of 25 numbers. After that, each number you receive should be the sum of any two of the 25 immediately previous numbers. The two numbers will have different values, and there might be more than one such pair. I'm not completely following it, but I'm just going to read through until the example input. For example, suppose your preamble consists of the numbers 1 through 25 in a random order. To be valid, the next number must be the sum of two of those numbers. So 26 would be a valid next number, as it could be 1 plus 25. Yeah, or many other pairs, like 2 plus 24. Okay. 49 would be a valid next number, as it is the sum of 24 plus 25. That's correct. 100 would not be valid, not two of the previous 25 numbers summed to 100. 50 would also not be valid, although 25 appears in the previous 25 numbers. The two numbers in a pair must be different. I see. Suppose the 26 number is 45, and the first number, no longer an option, as it is more than 25 numbers ago. Oh, I see. Was 20. Now, for the next number to be valid, there needs to be some pair of numbers among 119 or 2125 or 45 that up to it. 26 will still be valid. 65 would not. 64 and 66 would be valid. Okay, that makes sense. Here's a large example which only considers the previous 5 numbers and has a preamble of length 5. What's the preamble mean again? So Christmas starts by transmitting a preamble of 25 numbers. After that, each number you receive should be the sum of any two of the 25 immediately previous numbers. Okay, so the preamble is the amount of numbers sent at the beginning, and then we consider the previous 5 numbers. Okay, in this example, or maybe the previous 5 numbers is the preamble. In this example, after the 5 number preamble, no, that's preamble is the beginning. So 5 number preamble, 1, 2, 3, 4, 5 should be here. Yeah. Almost every number is the sum of the two previous 5 numbers. So 40 is 15 plus 25. 62 is 47, 15. Yeah. Okay. The only number that does not follow this rule is 127 in here. The first step of attacking the weakness in the Christmas data is to find the first number in the list after the preamble, which is not the sum of the 25 numbers before it. What is the first number that does not have this property? Oh, that's gonna be an interesting puzzle today. Let me just get the puzzle input. Oh, it's very long, huge numbers at the end. These are far larger than JavaScript can hold in an integer. Will we have to use the big int for this? Okay, I'm gonna save this puzzle input in our working directory. And I already have my setup code in here. I'm gonna put part 1 in here. Okay, then our inputs here, let me split it up to the right so we can view it side to side. Gonna get rid of this, and I'm also gonna remove the last new line, which I always do, so then we have a clean array when we split it. So yeah, that's what I'm gonna do first, is I'm going to let's think. So we get a preamble of what, 25. We get a preamble of 25 here, including this one. So that's our preamble, and then we started 36. So that's at least something to know. We started index 25, or the 26th number, and then for each number, as we go down the list, we have to figure out whether the 25 previous numbers, any of those two numbers, any combination, any two of those numbers add up to that number. So as we go through the list, we'll have to also adjust our previous 25 numbers as we go down the list, that those 25 also go down along with us, and then every time we need to find a combination if that to do. So finding the combination of two numbers is straightforward. In terms of code, how I can program it. It's just like shifting the list, the 25 numbers, shifting it up is a bit tricky, but we can do that as well. I'm thinking of, let me see if I can do this with functional programming and not imperative. I had to do a lot of imperative code yesterday. It was very hard to reason about, and luckily I managed to find a solution for the puzzle without too much debugging, but it's definitely harder to read and to trip over. So I always try to use functional whenever I can, because that's just much easier to fix if there's a bug in my code. So I need to stop. I need to go through the array and stop as soon as I find a number that does not have a combination that add up to it. So I guess I could use what's that method in JavaScript? Every, not every, but array sum. Yeah, array sum, but it will not. Will it stop as soon as it finds a true? If such an element is found, immediately it returns true. Otherwise, it returns false. Okay, not sure if that returns, but we don't need to care about that though. I can just find, exactly, I just find. Okay. I'll try and use find for the outer loop. I'm sure I'm gonna have to use another loop inside to go through those 25 numbers, but for the other one, outer loop, I can use So what are we looking for here? What is the first number that does not have this property, which is not the sum of the 25 numbers before it? So I can say const number without combination, number without some combination. That's going to be our answer for variable for the answer for the part 1. And so first we split the input with new lines. We get an array of each line, and in there I'm gonna say find. So what is one line? What is it's like an instruction or preamble? 25 numbers. We don't get anything more than a number. Yeah. So I'm just gonna say number. Not the most descriptive variable name, but here, number. So we don't care for the preamble. So if number, wait, I also need the index. I think index is the second. Yeah. So if index is below 26, then return false, because that's gonna be a preamble number. We don't care about that. So then we reached our first number which we need to check, and that's going to be 6 in here in this case. So let's create our 25 numbers that are preceding 6 that we need to work with. So I'm gonna call this variable previous numbers to find combination. I'm really bad at variable naming. What previous 25 numbers. That's good. Yeah, previous 25 numbers, and that's gonna be our array. Can we get our array in here? Yeah, we can, I think. What's array find value index object? I think that's an array. The third argument of find is an array, isn't it? The array itself. Let me see. Array. Yeah, great. So let's not this name array, but let's name this numbers. Good. So numbers is gonna be we need to slice. Oh wait, we need to slice the array, and we need to get a previous 25 numbers from the current index. So then we do index minus 25 and then up to index. Is that what we want? Let me just console log. Oh wait, I'm not going to use console log. I'm going to use the powerful debugger. So that's much easier. Let me add a breakpoint here, or after. Can I add a breakpoint on an empty line? Oh, I can. Great, because I need to have that variable. Okay, so it's there. So our first 17. We start with 17. Oh no, we skipped 30 for some reason, and we go up to until 6. Wait, what's number? 24. 24. Oh, okay. We already skipped the first iteration, so that's good. So 24. Number 24 has index 26. Yeah, makes sense. And then the array, and then is smaller than 26. Oh, wait a second. I need to say this needs to be 25, so that's why it skipped the first one. Let's run it again. Yeah, number is 6 now. Great. Yeah, so that's why we skipped the first one here. Go back in here. So yep, and then previous 25 numbers is just starting at the top 30, going until one before, let me see, one before, until 18. Yeah, the array looks good. Yeah, and I think slice does not modify the array in place. You're just returning a copy, so it's not going to affect other iterations. Shallow copy. Okay, that's good. So then now we have our previous 25 numbers, and we have the number we need to find the sum combination for. So we just go let's see, what's the easiest way to do this? There isn't a method really in JavaScript that I can use off the bat. I'll definitely have to do this by hand, looping through this array. And I don't know why it's getting big like this every time. Okay, and then so if I'll just go first number, and then I'll go through them, and then I'll use each number as a combination, and then I use the second one, and I can skip the first one because I already had it, and then I can go through it, and so forth. So I'll need two loops in here, two nested loops. Fun. Okay, so I could use find again. Could I use find again? Or return previous 25 numbers find. No, because that's gonna return one number. I need two numbers. Yeah, I need two numbers. No, we're not gonna use find here. We're just gonna use a for loop. So we can say for let first number. If there's not the first number, just number one. In lack of better creativity coming up with names. Let's see, so number 1 is smaller than previous 25 numbers dot length, and number 1 plus plus. It's not the number. Wait, why don't we do it like this? Const number 1 for an object for of array, so previous 25 numbers. So you have our number in here, and then we need to do a second loop for const number 2 of previous 25 numbers, but then we need to start at a different index though. Let's see if we can change this array. I think for of gives us the index as well. If we key value, so that's for an object, for a set. I think we get the index by saying, if we say index, I think this variable is going to be the index. Oh wait, we already have index up here. So index index 1 of number 1. Yep. So, and then here we need to slice this starting at this point. So then we don't go, so let's say for example we are at we have an array of 25 items. somewhere here. Yeah, the first one, here. So let's say we are like number 1 is 33. Then when looking for the second number that adds up to that number, we don't need to check these numbers anymore because we already had them, because 33 plus 10 is the same as 10 plus 33. So when we were checking for 10, we already checked for 33, this combination. So when we are at 33, we just need to continue from 19. So that's why we shorten the array. We have a different array in here. Shorten from index number, then should be good. Might be off by 1 there, not sure. Index 0 from index 0. Let me see. So if I have an array, index 0 is gonna just, okay, so it needs to be +1. Then it's gonna grab, yep, that's good. So if number 1 plus number 2 equals triple equals number, then we need to break out of the loop, and it's going to break out of this loop. We need to break out of the other loop as well. I can just have a variable outside here that's going to say let combination found, just like a boolean. That's gonna tell the outer loop that we found a combination, so it knows when to break. So combination found equals true. Well, wait a second, I need to grab these numbers as well. Okay, so I'm looking for a number that does not have. Okay, so I can move this up. I can move this up here, and I say combination found is true. And if I say if combination found is true, then also break out of this loop, this for loop. I just found out yesterday that if I don't know what plugin or IntelliSense does this, but if I just select the break, it highlights which for loop it belongs to. So if I select this one, is the outer loop, and this one is the inner loop, which is really useful. So that's neat. So I break, so that's good. But how about the case when we don't find a combination, which is the actual number we are looking for? So this is going to be true. Then combination found is true. And then, well, we can say return combination found. Yeah. So if we don't find a combination, then this is equals true, and then we found our number. Yeah. Let's give it a spin. Let's give it a first try and see how it works. Answer part 1. There. I have a breaking point in here. Let me remove that. Day 9. 6. Number 6. So I'm sure that's not correct. Let's put a breaking point. Let's go through the debugger, see what's going on. Where should I put it? I'm gonna put it here. Okay. Run and debug. Okay, so we get to this point. Number is 6. Number 1 is 3. Why is number 1 3? Should be 30. What's this array? So, oh, I need to cast it to a number because it's a string. So that's the first thing I need to do. Number 1. These are strings, and they need to be numbers. And our own number is also a string. So everything needs to be cast to a number here. Okay. I wonder if we get the same result. Maybe that was our bug. Yeah, 81. Still fairly early though. 81 is just here. I'm sure the answer must be somewhere in this vicinity. It must be much further than this. So I'm just assuming, I'm not gonna even try this number. I'm assuming there's a bug somewhere. So let's create a breaking point in here again and rerun it. So on our first iteration, we have number is 6, number 1 is 3. That's not right. So why is number 1 3? Which one is it grabbing? There's not even a 3 anywhere here. Is it 4 off? 4 off goes through iterable objects. Because there's 4 off and 4 in, and I always trip over which one is which. So this one gets an object, yeah. So and this one gets an array, so that's good. And it returns that element const of array. So our array destruction here might not work. Let me see. I do need the index though. It would be great if we could somehow get the index by using a 4 off and not have to go to the other type of loop. Can I just Google this? 4 off index JavaScript. How to get the index? Oh, index is the first, right? Index is the first variable, and then the actual number is the second one. So I need to swap these two. Let's swap this. Index of number 1. Yep. There. Okay, that's good. Let's give it another run. So index of number 1 is 1. Why is it 1? Should be 0, no? And then the number is 7. But this does not make any sense at all. How is number 7? Where's 7 even? There's no 7 here. And 1. What's the array? This is really weird. Number 2. 49. So we do have 49 in here. This is so weird. Okay, let me just number. So we are at here. Okay, because we skipped the first 35. So we have our previous 25 numbers, which looks good. It's just an array of, you know what I'm gonna do? I'm gonna map all these numbers to numbers. Oh, I might get a failure later on. What happens if I map this number to a number? Oh, look at that. JavaScript does support big integers like these. Okay, I'm just gonna map all these to numbers so then we can deal with them without having to do these typecastings in here. Much better. Okay, so we're sure now we're dealing with numbers. Let's run again. Wait, the breaking point never reached. Here, run debug. Oh, I think it gets an error. Yeah, the debugger doesn't complain if there's an error, which is very weird. 4 is not iterable. Four is not iterable. Why? Let's put a breaking point here. So it's an array with numbers. So why does it say that 4 of is not iterable? Oh, I guess the destruction here isn't correct. But then we get entries. Oh, maybe I need to do dot entries on the array, because how can you get the index? The loop does not offer any syntax to do these, but you can combine the structure and syntax introduced with calling entries method on the array. Oh, okay, so that was the trick. Good. This should be nice. Let's add a breaking point here. Okay, so we have number is 6. What's index of number 1? 0, number 1 is 30. Great, this looks much better. So we're here now, and then let's add a, we can put here, continue. Wait, I'm not sure where we are now. Oh, never mind. I'm just going to run the program, see what returns this time. This looks much better. Yeah, I'm gonna give this answer a try. Let's see, did we get it right or not? We did it. Yes, our first gold star of today is in. Let me deal with these bots in just a second. All right. Yeah, so we fixed or we solved the first part of the puzzle. Awesome. We got 1 gold star for that as a reward. Let's go to the second part. This looks good. Okay, second part. What is it about? The final step in breaking the Christmas encryption relies on the invalid number you just found. You must find a contiguous set of at least 2 numbers in your list, which sum to the invalid number from step 1. So what's contiguous? First of all, my English is not native. Contiguous, no results. Google to the rescue. Contiguous. Sharing a common border, touching, next or together in sequence. Oh, okay, so one of the other. You must find a contiguous set of at least two numbers in your list which sum to the invalid number from step 1. Which sum to the invalid number from step 1. So again, considering this example, in this list, adding up all of the numbers from 15 through 40 produces the invalid number from step 1, 127. Of course, the contiguous set of numbers in your actual list might be much longer. To find the encryption weakness, add together the smallest and largest number in this contiguous range. In this example, these are 15 and 47, producing 62. I don't fully understand this part. Let me recap. So, the final step in breaking the encryption relies on the invalid number you just found. So we found our number, and then you must find a contiguous set, so like a chronological set, one that follows another, of at least two numbers. So it can be 3, 4, whatever. It's going to be a big list, but it needs to be at least two, which sum to the individual number. So these numbers in here sum up to 127. What I don't understand is, so add together the smallest and largest number in this contiguous range. So that's 15 plus 40, 47. Oh, the largest. Oh, I see. Okay, so not the first and the last item number, but the smallest number and the largest number, which can be anywhere in that set, contiguous set. I see. And so those two added together is 62. And that's called the encryption weakness. Okay, so there's several steps involved here. Several steps involved. So our answer is contiguous. No, it's not the contiguous. It's the encryption weakness. That's what we need to find. Encryption weakness. And let me think through how we're going to do this. So we found our number, this big number, which is somewhere here, is here. So as soon as we find this number, we need to go again through the array, and then, well, this is interesting. This is going to be really interesting. We go again through the array, and then we start with the first two numbers. We add them together. Does that sum up to this number? No. Then we add the third number to it, the result of the first try. Does that lead to this number? No. So, and then we try the fourth, adding to it the fifth, the sixth. So we add, each time as we go, we add another number. We make the contiguous set larger and larger until we kind of like reach, we find the sum that's bigger than this number. If our sum of the contiguous set is bigger than this number, then we can then that contiguous set is never going to be valid. So we can continue from this number and then build up a contiguous set from this number. Oh, this is gonna take up a lot of iterations. What if I start the other way around? What if I start from this number, which I lost it here. What if I start from this number and then go back? And then go back. So kind of like iterate backwards. I can start with these two numbers. Well, obviously these do not add up to this, so I can skip that, and I'll have these two which don't add up to this. So I'll be skipping a lot of numbers in the beginning until I kind of like get here, and then I add 3 or 4 of these. It doesn't work, so I can go this. I think giving our input this way of iterating is faster, but that's just because we have like an incrementing input, which I think we always will. But yeah, it's gonna lead to a faster result. Although I'm not sure I need to optimize for that performance at this moment. Iterating through array backwards is much easier to wrap your head around than going forward. So I'm gonna give it a guess and just start from the top. And I hope the program is not gonna take too long to find an answer. I have not much of an idea how long it should. I mean, what are we talking here? We're talking about potentially a couple of hundred outer loop iterations times to the power of the inner loops. So those are going to be the same amount of numbers. No, so it's gonna, yeah. I'm just guessing like somewhere in the area of several tens of thousands iterations, perhaps 100,000 iterations. But that shouldn't be a problem for the computer. So let's give that a try. So what did we say here? We said that we need to find, well, let's first find the contiguous set. So we need to find a contiguous set. It's going to be the input. I'll need to split it again. But wait, what I can do though, can I? No, let me split the input. Yeah. And then I need to go through the input. So I'll need to, I'm not sure if I can. I have an array with a bunch of elements and I need to return. I need to first return like a section of that array. Is there a functional method which does that? I could use filter and like return true, but that's a bit hacky. I don't want to do that. Let me see. Do I even need to? If I have that array. Oh no, I don't need to do that. I can just I think I can just skip the variable declaration here. Okay. So then we have I'm going to use a for each number. So as we go through each number, and then we'll need to have it grab its index as well, and let's also grab a copy of the array. So what did we call the array? Numbers. Yeah, numbers. There we go. So then while sum is not equal, well, sum is smaller than or equal, then we can grab our answer from the first part here. So what I'm gonna do is I'm gonna create a variable here that's gonna be the sum. It's going to keep track of the sum of all the numbers we're adding, and it's going to start with sum 0, and then, well, we can start it with the number, and then we'll need to, no, I'm just gonna do something else. Perhaps do while loop is better fitted here, because I need to do some stuff before the while. So then do while, some more do statement while condition. So do this while, yeah, so it's gonna do it before. I think let's use a do while. I never use do whiles at work or anywhere in professional life, but solving puzzles leads you to obscure places of the JavaScript API. Well, yeah, so we need to copy paste this in here. So do while, our second number is going to be let me think. So we need our second number, next number. Let's say const next number. It's going to be index, this one, on the first iteration, and then we say sum equals sum, so sum plus equals next number. This seems well good. So what is gonna happen here? We're gonna start with 30, and then we're going to start the sum at 30 as well. We're gonna grab the next number, which is gonna be 17, and then we add the next number to the sum, so that our sum is gonna be 47 now. Is 47 smaller or equal than this? Yes, it is. So go into the next iteration, and then here we need to keep track of a different index. Different index. So let's say J, or you can say index nested, starting at index. Yeah, and then we can say index next nested, and then we can plus the index. So on our next iteration, index nested is going to be, it's going to grab the 44, and then it's going to add to the sum, and then okay, so then after we're done with the iteration, we need to find out whether we found a contiguous set or not, and we found it when sum equals our number from part 1, which means if we find it, then we have what's the section then of the array. So we index nested, let me think, it's gonna be +1, and then it's gonna check the sum. I think I need to move this to the top. So on the first iteration, index is gonna be 0, add 1 to the index, and then grab the number. Yeah, so that's correct. Calculate the sum, is it? No, then add another one. Okay, so that's good. So the index nested is gonna be the index of the last element of our contiguous set. So we can grab our contiguous set here, contiguous set. It's gonna be the numbers index nested, starting from index up until index nested, I think. And what does it say? The index to the end of the specified portion includes the characters up to, but not including the character indicated by the end. Not including the character indicated by the end, but I do need it though. So I'm gonna say index nested -1 then. And then index, the current number we need it as well. Okay, so then we have our contiguous set, and then we can just say I do a for each here. Encryption weakness is the sum of the lowest and largest numbers. So let's lowest, so not lowest but smallest and largest. Yep, smallest number, we just say math min contiguous set, and largest number is math max contiguous set, and those two added together is the encryption weakness. So we could console log our answer for part 2 in here, or let me see if I can just kind of like assign it to this variable somehow from here. I'll need to use a reduce. No, not a reduce, a reduce actually, because we are starting with an array and we return one number. So yeah, that's the only way to do that, is a reduce. It doesn't really matter what I put here. Doesn't really matter what I'm putting there either. That's just accumulator of the reduce function, and then here I return well, I'm not doing this right because it's gonna, I need to break out of this loop. It's gonna continue as soon as we find our right answer. It's gonna continue. And previously we used the for each. We can't use a for each to break. We can't break out of a for each. So I'm afraid we'll have to use a imperative loop. Okay, let's do that. Let's refactor this to a for loop. For const number. Oh, here, let's redo the trick. Oh no, index was first. Index number of I'm gonna call this numbers entries. Okay, so I'll just move this a little bit up. Yeah, so no functional programming, fortunately, for this one. So we have our loop in here, and when we, as soon as then we have, we need to break, but I guess we can just console log our answer here. That's fine. We could also assign it to a variable in the outer scope and log it at the end. Well, let's do that. Const encryption weakness. Now that needs to be a let. and then encryption weakness is going to be smallest number plus largest number. Okay, and then here we can log it. Answer part 2, encryption weakness. All right, I'm gonna give it a spin and see what we get, what happens. Undefined. Somewhere we're not doing the right thing. Let's add a break loop or a breakpoint. Okay, let's add a breakpoint in here just to confirm that we're doing the structuring here right. Okay, so index is 0, number is 30. Oh, I see. Let's do another map here. I should have really done this here. So numbers, input, split, map, number, and then here use numbers that find. Yeah, there we go. And then I can just reuse that here, so I don't need to do this 2 times. Okay, let's rerun it again. We should have integers now. That's an integer. Index 0. Okay, so the sum is 30. Index nested is the index nested plus 1. Let's add another breaking point here. So then index nested is 1. We grab the number, which is 17. That's correct. We add the sum to it. Let's add another breaking point here. So the sum now is 47. This is true, so it goes on and it goes on. Okay. The bug might have been again just because we were adding strings instead of numbers. No, still undefined, so that wasn't the bug. Let's add a breaking point here and see what happens for each. So for 30, we got a sum. We got a much bigger sum. What's our? Yeah, we kind of like went over, and we ended up with a section of 184 elements. So our first section, it checks up to here, and then it overflows. So this is obviously not equal to that one. So then we continue with the next one. So next one is 1, number 17. We get as big of an array as now. This looks good. I wonder why it's returning undefined. I guess because this is never true. It never gets in here. So our encryption weakness is just undefined. So it doesn't really find a contiguous set at all, and I wonder why. Am I doing something wrong? In this list, adding up all of the numbers from 15 through 40 produces the invalid number from step 1. Yeah. To find the encryption weakness, add together the smallest and largest number in this contiguous range. Well, we're not there. We never get to this part, so it doesn't find a contiguous set at all. And I'm trying to figure out whether that's because, well, it's smaller or equal. If it's equal, it's gonna add another number. Oh wait, so it needs to be, yeah, it needs to be smaller. No, wait. Yeah, smaller. Yeah, okay. Let's give it another run. Now we get not a number. So at least we got into here, so that's good. Then something we're doing here is not right. So let's add a debugger here, a breakpoint here. Okay, so we found a sum, we found a contiguous set. That's good. Our set is 15 elements long and it has all these numbers. So then we grab the smallest number. Okay, so here's where our bug is. Okay, yeah, because you can't, the argument to math min is not an array, it's just like a list of values. So you need to spread the array to get the smallest numbers. Okay, so now let's run again. Okay, smallest number, largest number, and then we're gonna add encryption weakness. Okay, this looks promising. Let's remove our breakpoints. So we get this number for encryption weakness. Let me try it. Let me try it. Moment of truth, ladies and gentlemen. 1 hour and 3 minutes in. It's pretty quick. We did it. Yes, we solved day 9. We got the second gold star. Awesome, and we did it in just an hour. That was much quicker than yesterday. I spent an hour and 45 minutes yesterday solving day 8. That's really cool. Yeah, and I'm pretty happy with the result we got so far. That doesn't look too bad. Let me close the terminal in here. And this one here as well. Yeah, it looks pretty, yeah, we did it in like 50 lines. One loop here with a nested loop inside. And then for the first part, we have a find method with 2 nested loops inside. I mean, it's not the most efficient algorithm, I'm sure, but it's readable and it's it gets us our answer in quickly. Awesome. I'm going to commit this solution and add it to the repository, so you can have a look as well if you're interested. Day 9 solved. I'm going to say git push origin main. So it should be, our code should be here. Day 9, great. I'm going to post a link to this repository in the chat. In case you're curious, you can find my solution for today's puzzle in there. And yeah, that was it. Oh, look at the map. The map is expanding. So Advent of Code has an ASCII art every year, and the ASCII art unveils itself as each day passes by. And the ASCII art for today is starting to look like our journey, because the story behind goes that we are on our way to a tropical island from the North Pole. So we kind of like started in the North Pole. We went down a mountain with a toboggan, and each day, the story for each day kind of like corresponds with the map, because on the second day you had to solve like toboggan problems, and here we were at the airport, and here we were flying and above the sea, and here we were transiting from the regional flight to international flight. So it kind of like makes sense. So today we were aboard the flight, on day 9, so we were here in the flight. So tomorrow is day 10. I can see we haven't reached the destination yet, so I'm assuming day 10 is going to be aboard the airplane again. So that's kind of how like the ASCII art is unveiled, which is really cool. All right, thank you for joining today's stream. I really appreciate it, and I hope to see you tomorrow. If you want to stay in touch, add me on Twitter _maximization. You can find it find my tag in the stream. So yeah, I'll see you tomorrow. Thanks for joining. Have a nice day. Bye bye.